The astronomer at Answers in Genesis and the Creation Museum in Northern Kentucky. I'm being joined this morning by Rob. Rob, why don't you introduce yourself real quick?
Hey, I'm Rob here, also known as Rocket Rob. You guys have probably seen some of my stuff on YouTube and seen me on the Answers News as well. I am the resident rocket scientist for the ministry, so I was in the aerospace industry for about 10 years, and Lori called me out here to the Northern Kentucky area where I can talk with you guys now, and I'm excited to be here, excited to talk about this awesome telescope.
And we're joined together here this morning here, at least in the Eastern United States. It's a little past 10 o'clock, and about a half an hour, NASA is supposed to go live with first photographs taken from the James Webb Space Telescope, which was launched on Christmas Day. It's been up now more than 6 months, and it took a while to unfurl it, get it ready, get it calibrated, and the science is just now starting. In order to review this, it might help if we showed a little video, I think about 3 minutes, from NASA that tells us about it.
Yeah.
This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Equipped with the largest primary mirror ever to be flown in space at 6.5 meters, it's more than 6 times the size of the Hubble Space Telescope primary mirror. Webb's 4 cutting-edge infrared instruments and cameras operate at super cold temperatures colder than the surface of Pluto. Getting this cold is done with the help of the largest sun shield ever flown, a 5-layer, tennis court-sized sun shield that blocks heat from the sun, Earth, and moon. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form and evolve? Are there chemical signatures of the building blocks of life on other worlds? Is our solar system unique? Launching such a large telescope into space is an incredible engineering challenge. Fully deployed, Webb is too large to fit inside any rocket fairing. Engineers designed it to be folded, like origami, to squeeze inside the European Space Agency's 5-meter diameter Ariane 5 rocket fairing. After launch, controllers on the ground deploy Webb remotely. Deployment is an intricate ballet. For nearly 3 weeks, controllers carefully unfold Webb. After this delicate dance, Webb's golden mirrors are precisely aligned using motors behind each hexagonal mirror segment, adjusting them to form one perfect mirror. Once the instruments are fully cooled, the exploration will begin. Webb is a technological challenge like no other, born of the efforts of thousands of people across the United States, Canada, and Europe. The James Webb Space Telescope is your telescope. Use it to explore, to challenge theories, to see sights yet unseen. It's yours to unfold the beauty and mystery in the universe and our place in it.
Well, that gives you an idea of what the space telescope's, this particular space telescope's all about.
Yeah.
It's much larger than the Hubble. It has something like 7 times the light collecting area, so it can do 7 times fainter. But it's also optimized, or actually entirely dedicated to the infrared. The Hubble Space Telescope was mostly in the visible part of the spectrum,
Right.
and they did the old infrared because the redshift in the universe, the Hubble relation, the most distant galaxies are extremely redshifted. And so in order to study them properly from the visual part of the spectrum, it's shifted way over to the infrared due to the expansion. They had to do that. And that's one of the two prime objectives of the new space telescope, the James Webb, is to study the most distant galaxies in the universe, which in a Big Bang universe would be the very first galaxy to have formed.
Yeah.
And the
Yeah, good point that you brought up. It's essentially not like the Hubble. They say it all the time. It's like the next generation Hubble, right? But it's actually a lot different because it's studying more of the infrared, like you were saying, and it's got different little functions and things like that. So that's definitely good to bring up for sure.
And the mirrors are segmented. It's not one big mirror like the Hubble Space Telescope had.
Right.
It's a bunch
Yep.
of little mirrors put together, actually big mirrors put together. They had to unfold in space. It was all packed up. They had to unpack the solar sail, all sorts of things to.
Yeah.
And
That was
we have
the coolest part. That was the coolest part. I think I wrote it down. There was like, I don't remember, but there was like hundreds of these failure points. At any one of these points, it could have basically doomed the mission out of all of those folding processes. So just as an aerospace engineer, I take off my hat to those guys because that was a tremendous engineering challenge to be able to origami kind of fold it up, because you're trying to take that sheet and try to fold it up. Imagine like trying to fold up a piece of string, right? It's not going to be deterministic. It's going to be kind of going all over the place. It's not really going to take that rigid shape. So being able to figure out a way to keep it all rigid and keep it all packed in like that must have been a huge challenge for sure. So,
and we have a colleague in the UK, Stuart Burgess. He's a creation scientist, and he's at a university there in the UK. And one of his specialties is designing stuff like that. He's done some things for them and the other side of the Atlantic to unfold in space. So when they say that creationists don't do science, that is not true at all.
Yeah.
Another engineering problem for the telescope is infrared detectors are affected by heat, because infrared radiation is heat radiation. If you put your hand next to your face like this, you can feel infrared coming off of your hand onto your cheek. We can't see it, but we can feel it. And if it has any kind of temperature at all, it's going to blind the detectors. So they have this big sun shield, a big insulated blanket that hangs out there protecting it's always in the shadow of this from the sun, and it cools the temperature. Do you remember what the temperature is it's cooled down
yeah,
to?
I'm just looking it up right now. I looked, I think the hot side was 185 degrees Fahrenheit, the cold side being negative 388 degrees Fahrenheit. So that's almost a 600-degree difference right there.
Yep.
And it's a 5-layer Kapton sun shield, and it's actually pretty awesome that the way that they did it, they basically layered it so that way there wasn't going to be as much heat transfer between each of the layers, and it was able to escape out. So by the time it actually got there, it was something like less than like a watt of actual power that actually made it to those instruments. So it was tremendously just
and I
awesome.
believe this is the first for a space telescope. There have been some infrared observatories before orbiting the Earth, and they were cooled with liquid helium or something like this to keep them cool. When the helium gave out, it was done. It warmed up, and it kind of blinded it. Kepler,
which I think they still have, because the Miri has to be within like 7 Kelvin, like 6 or 7 Kelvin. So they have to use an actual cryo cooler system. Essentially, think about the most effective refrigerator ever. So they still have to have that. But for all the other SIP systems, though, they're able to operate at that negative 388 degree Fahrenheit temperature.
And they're able to do this because they put it in a different position. It's one of the 5 Lagrangian points. It's not orbiting the Earth, which is another problem. If a thing goes wrong, you can't go fix it. It's out like nearly 1 million miles from the Earth.
Yeah.
So it's a one-time shot. This is an engineering marvel and a half. It's an incredible.
You talk about the redundancy they have to plan into it, like you were saying, because they're not going to be able to just go up like the Hubble. They could at least send up astronauts to be able to make those fixes. But here, that's 1 million miles away to have to send out someone or a rover or a probe. That's just kind of unfeasible at this point. So the redundancy they had to to build into that was amazing, and being able to have all these fail safes. So if something did go wrong, at least you would have redundant systems that would be able to kick in. That's typically what a lot of times you do with a lot of these systems that are going up in orbit. Especially back in my rocket industry days, we would launch up a satellite, and it's not like you could go up and try to fix it as it's making its way up into orbit. So you had to make sure you had a lot of fail safe, a lot of redundancy. So basically take that times like 100, basically what they were doing in terms of making sure that if something did go wrong, they had multiple points that they could fall back on. So that I thought that was pretty awesome.
And people need to be aware of something else. Since we don't see infrared, and this telescope entirely observes in the infrared, then any of the images you see from it are false color. Now, there's one right there. They released this one yesterday. It's a deep field photograph, 12-hour exposure or 13-hour exposure, I'm told. But you see the nice yellows and blues and reds and so forth. Those are not real colors because, well, infrared, we can't see it. So what color would you pick up on? So what they did for that and other photographs as well is they color code them. They can do different things. I'm supposing the blue is more for hotter or for shorter wavelengths, and the red more for longer wavelengths, but I've not really heard what they're talking about there. Those blue points in that image are stars within our own galaxy. The yellows and reds, those are galaxies that are literally billions of light years away from us. And then there's gravitational lensing in it as well. But it's always important that you realize these are not true colors. Not that they're faking you out, but you have to color code them somehow, otherwise you couldn't see them.
Yeah, and then Danny, you've actually taken a lot of photographs yourself, right? And you even have a new book called The New Heavens out, and talks about a lot of the beautiful photographs you have, like some of the ones you've taken at the Grand Canyon in Arizona. Why don't you go ahead and share some of the cool photographs you've done?
Yeah, I got into astrophotography just a few years ago. It's kind of funny, I never did until then, but I go on a raft trip every year, every summer for a week. There I am jumping off, doing a belly flop. And it's a lot of fun. We do geology by day and astronomy by night. We get to play in the daytime. But anyway, at night, I set up my cameras and I take this photograph, the one earlier, those are 30-minute exposures. And this was looking to the north, that star near the middle. That is the Polaris, or the North Star. You can see the Milky Way smeared out on the right. That's looking through a break on the canyon wall there, I think probably in Grand Canyon itself. And then the other one was looking to the south, and it was smeared out because of the rotation of the Earth. Those trails are longer there because you're farther from the 2 points in the sky around which the sky turns. Now, I also do some time-lapse videos. I really like those. So got a video we can show you here. And that video, these are 13-second exposures I took at ISO 6400 with a wide-angle lens. Those streaks running across, for the most part, are airplanes. You see the Milky Way there. By the way, one of those points in that ridge there is the Desert View Watchtower. If you go to the east end of the Grand Canyon South Rim, you'll see that. We're camped down on the river there. And as the night progresses, a few clouds come through. The sky starts to brighten up a little bit at one point, about right here, because the moon rose. You can see some moonlight on the rim there, coming down a little bit, and then dawn takes place. And that's about a 5 or 6 hour run, I think, taking place there. And those are real colors. The eye may not be able to pick those up because your cones, your color sensitive cells are not real. They need a lot of light to get tweaked. So we generally see in black and white with our rods, but the camera can pick those up because it's pretty sensitive. Again, 13-second exposures on that. I had several hundred photos put together in that time lapse. I love doing those. And the book you mentioned, The Heavens, A Different View, that came out last December. And it features some of my astrophotos, but actually more astrophotos from 2 amateur astronomers that have helped me out quite a bit. They're incredible photographers and astrophotographers. And when I take some photos, I think I got a pretty nice one. I see what they do. And I think, why do I even bother? So Rob, you used to work for NASA. What exactly did you do for them?
Yeah, so I worked on multiple different programs. One of the programs I worked on was called MAVEN. MAVEN was a really cool program. Basically, it was one of the Mars orbiters that went up, and basically its job was to study the atmosphere. So it did a lot of what's called deep dip missions. So it would deep dip, like within 100 kilometers into the atmosphere, collect a lot of cool kind of science there. And at the same time, being a Christian was always challenging working on a lot of these programs because like Maven, for example, and Insight, they're steeped in evolutionary kind of worldview kind of goals as well. Basically, they're always looking for, like that life on Mars and water on Mars and trying to find the organic materials that are needed for Mars. And so, but from my perspective as a Christian, I was basically admiring the awesome creation of God and God's handiwork. Like it says in Psalm 19:1, the heavens declare the glory of God, the skies proclaim his handiwork. And, being able to look at his creation was for me an awesome, eye-opening experience, being able to just experience all that. And one of the cool things I always loved about Maven, so I was part of the guidance, navigation, and control team, right? So my job was always the guidance and navigation of the satellite, making sure it was pointed in the correct attitude and pointed in the correct way, and made sure that as it was going through the atmosphere, our roll pitch yaw was always maintained. So one of the cool things is the telemetry would come in, so I'd be sitting at home eating dinner with the family, and all of a sudden on my cell phone, I would start getting text messages from Mars. So basically our satellite telemetry would come to my cell phone and then pop up all the telemetry data. So I was able to look at it, live on my cell phone.
No. Was it actually texting? I mean, sending, hello, Rob, I'm doing fine here. What was it?
Yeah, so we had all sorts of fun stuff. So it would basically it would hit our deep space network antennas, right, and then it would get piped to our operational control center, and then from the center, then we would pipe them out to different cell phone numbers. So I was on that list of one of the cell phone numbers that were there. So yeah, we would have things like, hello, I'm doing fine today, or hello, I have a bad cold today, and maybe you should come check me out. And so we'd have a lot of fun stuff like that. And we would have all the numbers and telemetry that I could look at, in terms of what's the actual roll pitch yaw angles that we're seeing and all that fun stuff. And so that was a really cool mission. One of the other fun missions I worked on was called Antares. It was the resupply mission, basically up to the ISS, International Space Station. So we would load up different cargo, supplies, food, even animals. Sometimes we even launched mice one time up to the International Station for the astronauts for their science. And so that was a really cool, fun program, being able to launch things up to the astronauts and be able to provide for their needs up there. And we had some really interesting payloads. One time, like for Thanksgiving, we decided to launch up a whole turkey dinner for them. Turkey, mashed potatoes, cranberries, the whole 9 yards, because we got to launch that up for them. So that was always a good time. Just a few of the programs I was involved with over my 10-year time in the aerospace industry. So,
yeah. Well, you mentioned Maven, which went to Mars, and that kind of jogged a memory for me. A little before your time, you were a little kid at the time, but back in 26 years ago this summer, there was an announcement of possible life evidence of life found on Mars. It came from a rock, a meteorite found in Antarctica. It's called Allen Hills 84001. And they were studying it there in the mid-90s, and they found 4 different things and microscopic views of this rock they thought were maybe fossilized life, and caused a big uproar. And at the time, President Clinton actually went out and got in front of this and had an address to the nation about this. And that was good. That was big news. If there's life on Mars, or if there ever was life on Mars, that's a huge story, and it's quite appropriate the president would get involved. Turns out there were about hundreds of papers that followed that refuted every point those things made. So it kind of quietly died, but it took a while. I remember for 8 or 10 years afterwards, people would tell me, yeah, they found life on Mars, and they didn't know about all the other contradictory, conflicting reports that really kind of smothered it. But it was reminded me yesterday, I got wind late Sunday night that President Biden was going to go on yesterday at 5 p.m. With some sort of announcement from these photographs, and preempting, by 3/4 of a day what we're doing this morning. And I thought, well, that must really be big. I mean, just like Bill Clinton did in 26 years ago. So I went out yesterday on my Facebook page, and I asked people, what do you think he's going to say? And I said, it ought to be big. So I made my prediction. I mentioned a few moments ago about one of the objectives of the James Webb Telescope is to look at distant galaxies at high redshift, but also it's optimized to do spectroscopy and maybe some imaging of extrasolar planets orbiting other stars. and they're looking for atmospheres and maybe even diatomic nitrogen atmospheres, which is what the Earth's atmosphere is like. So I was expecting something like that, that would found an Earth-like planet. So I was a bit disappointed that they simply showed us one of the big five they wanted to look at, and this is a cluster. It's called SMACS J0723.3 minus 7327. It just kind of rolls off the tongue, doesn't it, Rob?
Yeah. Say that 10 times fast.
We came on with we had somebody commenting earlier that according to Psalm 147, God counts the stars and names them, and I think his names are pretty good. Our names are, for the most part, just catalog entries, gibberish. If you don't know what that name, by the way, means something, but other than astronomers, it wouldn't mean anything. But it's a cluster. It's about 5.5 billion light years away from us. And that's a pretty impressive image. Can our staff people or tech people put it in front of everybody, everything we got, if we can, just so we can see it better? Again, I emphasize that the blues and the reds, thank you, the blues and the reds and the yellows you see are not true colors. These are infrared images. You're seeing the cluster, those little the little blue things with the spikes on them. Those are stars within our own galaxy, only a few hundred, maybe a few thousand light years away from us. But those little smears of light that are various colors, those are all galaxies in this cluster. I just gave you the name of a moment ago. And then what's truly interesting is on the perimeter of that cluster, or near the center of, you'll see these little streaks that are in arcs, and they kind of have a center on the middle of that cluster. And that's gravitational lensing, something that Albert Einstein predicted a century ago, wasn't confirmed until a few decades ago, and now we're seeing it more and more. And if you look at the lensing on this, you can infer, measure the mass of that cluster of galaxies, which is a really cool thing to do. But what I noticed in this image is that usually you just get little streaks and they're narrow, but these are extended a little bit. They're not just little streaks of light. They've got an actual image of the galaxy that's been just kind of spread out because of that lensing effect. And I've never really noticed that before in images. The resolution on this is incredible. I'm really impressed with it.
Yeah, I think they were showing actually some of the side-by-sides of what Hubble took and what this one took, and it's just it's stunning the amount of clarity you get with James Webb versus Hubble in terms of this similar type of sky that we're actually looking at here. I thought that was pretty cool. That was pretty awesome. Yeah, and then I also thought it was interesting, but with the whole gravitational lensing that you're seeing around that, being able to see those galaxies stretched. Would you say that it's safe to say that those stretched galaxies, those are essentially the same galaxy that we're looking at, or are those multiple galaxies?
No, those are galaxies that are far beyond it. We're here, and the cluster is here, and the galaxies we're seeing lensed are way over here. So the light comes past the galaxy cluster, and then it focuses back to where we are, like that.
Yeah.
So it's acting as a lens. So we're seeing even more distant galaxies. The cluster itself is 5.5 billion light years away. Some of those lensed galaxies might be on the order of 10 billion light years away.
Yeah.
We don't know yet. We may never know, but we're seeing far more distant galaxies there.
Yeah, absolutely. And I think this might also be a good time to bring up the fact that these light years, these billions of light years away, they are a unit of distance, not time, right? And so I don't know if you want to talk a little bit about what that worldview, what that assumption looks like, why people think that when we're looking billions of years away, we're actually looking through time, that essentially this telescope is a time machine. I don't know if you want to spend a couple minutes.
That's getting what we call the light travel time problem. We believe from scripture the world is only thousands of years old. I think a little over 6,000 years. So people ask, well, how could we see things that are billions of light years away, like we're seeing here? Or if that matter, the Andromeda galaxy, which is about 2.5 million light years away from us. How could we see that in a recent creation? And again, it's very important to realize that a light year is a unit of distance, not a unit of time. If light travels and always has traveled at a constant rate, then it does seem to present a problem. Now, there have been many solutions people have offered over the years for this problem. Creationists have offered. My solution is that God performed a miracle on day 4. If we look at the creation week, there was miraculous things going on entirely. We don't have normal physics, as it were, going on. You have non-living things, then you have living things pretty quickly. You didn't have anything existed, and then there did exist all these things. And those are violations of how science or how physics today works. So everything about the creation week was miraculous. Not only did God miraculously make the heavenly bodies on day 4, but he rapidly brought the light to the earth, just as he caused the plants on day 3 to rapidly grow out of the ground, just as he did on days 5 and 6. The birds and the land animals were miraculously made out of the dust of the ground, like man was on day 6. A lot of processes going on, very rapid, very directed. So God brought the light here so we could see them. If he didn't, then the functions and the purposes given to stars on the day 4 account could not be fulfilled. The stars had to be visible. So I fully believe at the end of day 6, beginning of day 7, when Adam and Eve looked up on their first night on Earth, first night anywhere, they saw pretty much what we see today.
Exactly. Yeah. And if you guys want to learn more about in terms of what kind of models are out there, I think on answersgenesis.org, you guys can just research that. There's a whole bunch of different models that you guys can look at there. And one of the analogies I always like to think about is like a flashlight, right? So you turn on the flashlight, it basically converts electricity from the batteries into light, right? So, and it's absurd to think that, you know, it converting the electricity to light is essentially the same way the flashlight was created. Right. So you think about how that kind of works in terms of it wasn't created that way. So something that operates in a certain way doesn't always mean it was created in that same way. So, and typically a lot of these guys that are looking at it, that are propagating these evolutionary worldviews, really based on the naturalistic worldview, basically says that all that is out there is just nature. It's just matter in motion, right? It's just chemical processes over millions and billions of years. Whereas our stance is from the biblical worldview that starts with Genesis from the very beginning, that says God created the heavens and the earth, right? And like Danny was saying, day 4, you know, that's why we have the sun, moon, and stars. It's for our seasons, and it's actually for a purpose for us, and it's for our benefit. And so you see that compare and contrast all the way through and through. And that's just, I think, one of the really important things that we have to remember in terms of we all have the same evidence, right? We all have the same stars, the same matter, energy that we're looking at the universe, but how are we interpreting that evidence? Are we starting with the biblical, with God's word, or are we starting with a naturalistic, really a man-made opinion that's basically shifting every single, I don't know how often they usually shift their theory, you know, over the years and the decades, you know. So you think about the sinking sand versus a solid rock foundation. Which one do you want to build your house on? Is it going to be God's unchanging word that doesn't change from generation to generation, or are you going to be basing your beliefs and everything else on the shifting opinions of man, is what it comes down to. So I think we're getting a lot of questions in our comments. I don't know if we want to address any of these here.
Well, one question came up here is, what did evolution expect to see in the deep field? And well, they actually see, I'm not sure they expected to see anything particularly. This is just a test run. They wanted to look at this particular cluster of galaxies and get that lensing gravitational lensing taking place. And I think the real part will come when they spend even more hours gathering spectra and images of the most distant galaxies in the universe, because we talked about the light travel time issue. We think that we're seeing these things something close to real time. You know, thousands of years compared to billions of years is close to real time. But the evolutionists, when they see a galaxy at 10 billion light years away, they're looking at it not as it exists today, but as they did 10 billion years ago. And then if it's 11 billion light years away, 11 billion years ago, and so forth. Well, they think the universe is 13.8 billion years ago. So if they can find galaxies that are, say, 12 billion light years away, then you're looking at galaxies that would be in the infancy of a Big Bang universe. And they're very curious, where do galaxies come from? How do they form? That's still a big issue, big question that astronomers have today. And the hoping that the James Webb Space Telescope will literally and figuratively shed light on those kind of questions. My expectation is that we're going to see galaxies that are fully formed. I think they're going to be very close to what we see today. There'll be some systematic differences in color and brightness, perhaps, but who knows? We don't really have a good, well-developed creation model of cosmology. It could be we will be seeing galaxies much closer to the creation event of day 4. I'll be curious to see. We just need a paradigm to interpret those things.
Right. Yeah. It'll be interesting to see how they react when they actually look at these really, really far away galaxies, which truly are very far away, right? We're not denying the fact that they are really far away galaxies, but they're basically going to see very fully formed galaxies and stars and all the rest. And it'll be interesting to see how they're going to go back now and try to tweak their Big Bang theory to try to fit the evidence, right? Because it's don't let the evidence get in the way is what we always like to say here. And it's definitely going to be interesting how they're going to try to attach to their worldview at the same time, reject the clear evidence of God's creation in the universe. I mean, you just look up into the night sky for a second, for a sec, you know right away that the true God of the Bible exists. Just from the general natural revelation around us. The heavens declare the glory of God, but they suppress that truth in unrighteousness, and that's what we're seeing with a lot of these scientists working at NASA and all these different agencies as well. So.
Looks like they're going to be unveiling the first of the images in a little over 3 minutes.
Yeah, we got a few more minutes here.
Yeah. But we ought to maybe look at some of the questions that have come up. One, Senator Bergerman, she asked, is the universe expanding and are stars being created today? The universe is expanding. Well, Edwin Hubble gets credited with that discovery in 1929, almost 100 years ago now. What he actually found was a relationship between redshift and distance. Now, redshift refers to wavelengths of light being shifted to longer and longer and longer wavelengths. And if galaxies are getting farther and farther apart from one another, you would expect a relationship between distance and redshift, or the rate at which they're getting farther apart from one another. So what he found was a correlation between redshift and distance. Now, the interpretation of that Hubble relation is that the universe is expanding. That's the simplest, most straightforward explanation or interpretation. But there could be other interpretations. Fritz Zwicky, who played a key role in dark matter years ago, he never liked the expansion idea, and he proposed the idea of tire light that some people still talk about. Personally, I think expansion of the universe, since that is the simplest, most direct interpretation, I think that's probably what's happening. The universe is expanding. I wouldn't want to die on that hill, and I'm certainly open to other ideas. But for now, I'm trying to interpret biblical cosmology in terms of that expansion. And then as far as stars, she asked us about stars, I think, being created today. And again, I don't know. A lot of creationists think not, because God created stars on day 4 and he stopped creating. He also made horses and dogs on day 6, but yet there are horses and dogs being born today. So they're replacing, I guess, the horses and dogs as they die off. They're multiplying and they're being fruitful. Stars are never said to do that, but we do sometimes talk about stars dying, and they will wear out. So is God providing for new stars today? I don't know. I do think there's some real problems with the physical processes of how stars might form.
Which we've never observed a star actually forming, right? I mean, that's something that we've never observed, an actual star forming.
Yeah.
That's
the problem with that is that according to the natural processes, it would take an awful long time. It would have taken like 30 million years for the sun to form. Yeah, and we just haven't been looking that long. So sometimes you hear about a discovery, the news story that astronomers discovered a new star as if it wasn't there last week, it was this week. Yeah. And that's not what's going on. They take snapshots of stars that they think were born in the last few million years, and we weren't around to see it not there to start with.
Yeah, let's go ahead and listen in here, see if we get any audio from this NASA feed. Sounds like we're going live here.
Of course, these things never start on time.
Well, yeah, I was trying to watch the one with President Biden last night. I think they were like an hour and a half late, and I'm like, come on now, let's get this show on the road. All right, here we go. We got something coming in.
Skywatchers, this is it. This is the day we get the first science images back from the James Webb Space Telescope, and you've got a front row seat to the cosmos.
Front row.
I'm Michelle Thaller, your host for what can only be described as a celebration for everyone on Earth. So think about this. Light from the earliest days of the universe has been traveling to us for billions of years. Just over the last few weeks, we've captured some of that light with a telescope that sees the universe in an entirely new way. And today we share the very first results. So longtime space fans are going to know who this is. This is Dr. John Mather. He's the senior project scientist for the Webb Telescope and a Nobel Prize winner. And John, I couldn't be happier to be here with you today.
Thank you. It's a thrill to be here for this very special day.
How are you feeling?
I am thrilled and I'm relieved because you know when you start something this big, you know there's always a possibility. It might not work. It did work. We are so proud.
$10 billion
You've been on this
gamble
project
there.
for a very long time, right?
Yeah, started in 1995. We had just finished measuring the Big Bang. We measured it with a Cosmic Background Explorer satellite that we built right here at Goddard.
Measuring the Big
And
Bang.
we measured the spectrum. We measured there are hot and cold spots in the Big Bang. So we said, now we know it all, how it all got started. But then what happened after that? So then I got a call from NASA headquarters. Would I like to work on this new telescope that's going to help answer those questions? What happened after the Big Bang? How did the galaxies grow? How did
So you
the
see that
black
circular
holes
reasoning
grow?
going on to begging the
What
question,
happened all the way from here to
assuming
here?
evolution to prove
So This is
evolution.
our time machine, and I just wanted to be part of it. I am so thrilled that we got a chance to do it.
One of the things that I remember you saying, and this is kind of amazing, that after you win the Nobel Prize, you thought that this mission was the most important thing to work on.
Absolutely. It's the next question. After you know how it started, what happened then? And
He got the
suddenly
Nobel
we now
Prize
have
as the
technology
leader
to
of the
do it.
group
We didn't
that
have
found
50 years ago.
fluctuations
We didn't
in
have
the
technology 25
CMB,
years
the
ago, even when we
cosmic
started
microwave
this.
background. That
We
was
had to
back in
invent things along the way,
1991,
so
I
we
believe.
did that, and here it is.
Well, thank you. We'll be back to you in just a moment. So at the moment, we're going to talk about the way that Webb is a completely new way to explore the universe. So today, the mission releases its first science images and gives wings to the dreams of so many people who worked so hard for so long to make this possible. For everyone on Earth, this is your telescope. This is the largest, most powerful observatory ever put into space. It's the product of thousands of people working for more than 2 decades. This is a mission that's singularly focused on the biggest questions in science. So the following phrase is often used too easily, but today actually does mark the dawn of a new era. Today, the Webb mission is open for scientific business, and this is just the beginning. The best is yet to come. So, John, one of the things you told me about is that you really want to make sure there are some people that get thanked, people that put a huge amount of effort into this.
Absolutely. Our current project manager, Bill Oakes, took the project from a time of trouble when we didn't exactly know how we were going to get this to work, and got it all the way to the end. Here it is working, and it's because of Bill made this worldwide team, 20,000 people around the world
I was
were
like, you're
involved
gonna
in making this
talk
thing
a
all
while
work, and
until
Bill
we
has
actually
been
see
there
these
every
images
day,
here.
making sure that it would happen.
I don't know if you want
Other special
to chatting
person is
on
Senator
answering
Barbara
questions,
Mikulski.
Danny, as we
She
wait, or
saved our telescope.
Well, I
and she
wanted to
saved
say
the telescope
hi to
before
Patty
us.
Ann. You
She
know,
made sure after
I
the
sat
couple
behind
telescopes
her
were
in
launched
ninth
and it was not
grade
in focus,
All
world
right.
history.
Fix it. She made sure
That's
that
great.
I haven't seen her in years,
Webb
and we do
telescope needed
communicate
more
via
resources.
Millions of
social
years
media.
ago.
Get that.
Yeah, more than a few years ago. Yes. It was not billions of years, though.
It's an honor to be with
Yeah.
you, Jay. I mean, it's been a pleasure to be working with you through this whole thing.
Time
Thank
is
you so
relative,
much
right?
for
As you get
inspirations
older,
and
Danny,
joy.
right? Time tends to speed up, go
So
faster.
this broad
Oh yeah, I
looks
was
like
in
Webb
high school
Time
just a few weeks
is
ago.
a
Yeah.
partnership.
Yeah.
On our journey to explore distant places in space, we've been joined by intrepid travelers from around the globe. We have so many extraordinary collaborators. So let's check in with our partners who will be sharing the stage with us today as we reveal Webb's 5 first science images. From the European Space Agency, I'm joined by Katie Haswell in Darmstadt, Germany. Katie.
Hello to Eric Hovind as well.
Katie in the background there.
Yep.
Also joining us.
I gave him a little nudge. I talked to him yesterday.
We have Natalie
Yeah.
Gillette and Sarah Gallagher. Bonjour.
By the way, Eric, my kids absolutely love your guys' Night at the Creation Museum, Night at the Ark Encounter movies. Just wanted to throw that out there. They're like obsessed with those two short movies you guys made. So
And you know, Rob, that was Teddy's first film.
yeah, Teddy Bear, yeah. He was like sitting there slapping Eric the whole time back and forth. That was great.
Oh yeah, he enjoyed it. He said.
It's like, why are we hitting each other? Yeah. My son RJ, he's 3. That's like one of his favorite quotes he says all the time, and then he's always saying, Danny Faulkner's not wearing any shoes, because he wasn't wearing shoes in that scene either.
We have a signal
So.
from Bhopal. Yes. Excellent. Welcome to NASA. Hello, everybody there. Wonderful to be talking to you today, all the way in India. We'll be back to them later, yes?
India.
Great to wave to you. Hi, wonderful. And we also have a warm welcome now in Portland, Oregon. So we have them feed from Portland. Bit
Well,
dark. Is everybody
Ian
there?
Davidson asked here, the stars in the image look fully
Very
formed. If they're
auditory, my
looking
friend. Okay,
back in
okay, we're
time,
actually
wouldn't
gonna
they
go
see
back
stars
to
forming?
Milan, Italy.
That's kind of the argument.
Afternoon in Italy,
Yeah.
15 in Italy.
They're not seeing back far enough into time. I think they would
I just
say
got a screen from Italy.
those stars you see, the little blue spiky
And
things,
next
those
week
are
I'm gonna take a look
within
at
our own
them.
galaxy, only a few
So
hundred or
look
few
for
thousand light years
over
away.
to us.
The
Hi.
galaxies we're looking at are
Nice to
5.5
see you.
billion
Thank
light
you
years
for being part
away.
of this today.
The lens galaxies are
Going in a
much
little bit
farther.
further afield.
Who knows
Mhm.
how far away they
Tanya,
are?
Israel.
But
Hello.
you can't see individual
Israel.
stars that far away. They would say
Hi.
many of
Nice to
these
see you guys.
distant galaxies are forming stars at prodigious
Okay,
rates,
one
but
more for now.
you can't see that
I see
taking
people like
place.
giving me hugs.
Yeah.
Okay, we also have Vancouver,
Yeah.
Canada.
Right.
Hey, Vancouver. Hi.
Danny
All
has
right.
shoes
Wonderful,
there.
wonderful. Yeah,
I
lots of
do.
people with you. So
There you
right
go.
across from the campus from me, there's also a huge watch party taking place with members of the Webb team. So the wonderful thing is that they actually are people that have worked on the mission, and they are part of our
Will
NASA
Dr.
Alliance
Lyle be
for
updating his
Webb
recent work? So I don't know.
Hello,
I haven't
hello,
talked to
Webb team.
Jason in quite a while. We all need to update our work. I have a couple of things I need to update. I haven't
There
done
they
it yet.
are. Yes.
Hmm.
A lot of
Not enough
people.
hours in the day, it
So
seems like.
it's incredibly important to me personally, and also to all of us at NASA, that the
The
universe
kids
belongs
thought
to
Teddy was too
everyone.
scary, and I
And we are proud to share its
don't think we got
flavor
around to
with
watching the
everywhere
Ark one.
We'll say hello to some more later in our broadcast.
Oh,
NASA
he's
is
even worse than the Ark one because Teddy
one
Bear, like,
field
he
that
pops out,
will
you know,
Oh,
like
yeah.
in that little
processed by the
kind of like
Webb
the
science team.
spooky animal
And it's only a
area
handful of
exhibit
experts
parts,
Yeah.
who've
and
seen the
Teddy
Yeah.
like
images so
pops
far.
out of the
And I can
window.
tell you that we
Yeah,
are
that
so
part's
excited
that's
to
the
wrap
scary
it for
part right
everyone.
there.
Yeah.
We'll be
Maybe
releasing each
we should give a
image in turn
PG-13 rating at least to
Yeah.
those
As
few
you see
movies.
it on this broadcast, it will be available for download
Yes.
on the internet. On the screen below, you can see a timeline showing where we are in the show and what's coming up next. And by the end of the show, all 5 images will be available to everyone. So hopefully you can tell I'm excited. Okay, so let's do this.
All right, looks like we're seeing something coming up next.
Yeah, this is the one they showed yesterday, the deep field,
Yeah,
which is good to look at again. I think that's a really cool photo. I love it.
yeah, that's really cool.
Okay, we're going to release the first image right here at NASA Goddard Space Flight Center, Maryland, and we're just outside of Washington, D.C. NASA Goddard is home to the project office of the Webb Telescope, and the observatory portion of the telescope, the mirrors and the science instruments, were integrated and tested here before launch. So for many of us, including myself, seeing Webb come together bit by bit right in front of our eyes was an emotional and very inspiring experience. So it's kind of like a part of us was out there with Webb right now. A million miles away, part of our hopes and
Back in
dreams
here.
are out there. So I'm joined now by Jane Rigby, the operations project scientist for the Webb mission.
Yeah.
And she's a familiar face for people who've been following
This
us
might
before.
take a while.
Welcome, Jane. Hi, Michelle. Okay, so Jane, you not only get the honor of revealing the first
Love to
image,
tease us,
but
don't they?
This actually got
Yep.
a little bit of a sneak
Get
peek.
to the
So I think
photos!
very select
Come on,
audience has already
let's
seen the
go.
image.
Yes, so last night,
No one got time for this.
On
Come on.
behalf of the project, I had the privilege of traveling to the White House with the NASA Administrator Nelson and other senior staff to share our first image with President Biden and Vice President Harris. And it was really fun. Oh my gosh. They really geeked out. We had a closed-door session where we got to walk through all the images and just share the excitement. And they were so thrilled, and they got the profundity of what we're seeing. And so now we're going to...
Oh, Ken Sly from California. Hello, Ken. I'm glad you're here.
Ready to put the first image up.
Oh, let's do it. Let's do it.
Absolutely. All right, here we go.
Here's the first one.
So the first image is a deep field.
Oh, gorgeous.
And it's also a deep
This
field
is the
with a
one from
cluster. So
last
why
night
don't
with
we go
President
through this
Biden.
just a little bit. So if we come up and look at this image, first of all, it's really gorgeous, and it's teeming with galaxies. And that's something that has been true for every image we've gotten with Webb. We can't take blank sky. Everywhere we look, there's galaxies everywhere. And so, this image, as we're looking at it, what we're seeing is not just all the galaxies, but there's a cluster here. And so the cluster are all these white, kind of ethereal galaxies. We're seeing them as they looked back in time, right? The speed of light
There you go.
is
There's
really
naturalistic
fast. And
assumption
so as
again.
we're seeing distant galaxies out in space, we're seeing them as they looked billions of years ago. So these cluster galaxies, the white ones, we're seeing as they looked about the time the sun and the earth formed. And then behind the cluster, we have the gravity of the cluster is distorting and warping our view of what's behind. And so there are these galaxies that look stretched and pulled, kind of like they've been magnified because they've been magnified by the gravity of the cluster, just like Einstein said they would. And it's really, there's so much detail here. We're seeing these galaxies in a way that we've never been
It's
able to see
all
before.
stars.
There's just
Yep.
a sharpness and a clarity we've never
Stars and
had.
galaxies.
And so we can look at, if we zoom in on this image, and I encourage you as you grab this image at home, like zoom in. You can, really zoom in and play around. There are galaxies here in which you're seeing individual clusters of stars.
Eric brought up a good
popping
question
up.
here,
So
Danny. How much deeper is this image than the previous deep
and
field
then
from Hubble?
we also see
You have an
The
idea?
deep field, yeah, the deep field was hitting,
this image
8,
kind of
10 billion
littered
light
like
years.
jewels
This
all over
one's,
back
the
of the
cluster's
image.
5.5 billion
These
light years. The more
red
distant
galaxies.
lensed galaxies we
Now,
don't know.
that was what
So I
we
would
built
say
this
offhand, it's
image to
probably
do.
not as deep. And remember, that was like
The most
33
distant of
hours
those
exposures. This is
are
only 12 or
billions of years. We're
13.
seeing
Yeah, it's only
some
12.
like
Yeah.
more
So
than
if they do a similar
13
thing, they're going to go
billion
deeper
years
for
ago.
sure.
And so
Right.
galaxies like that one right there, this little red guy, you're like, okay, yep, what is that? Well, Webb got spectra to figure out what those galaxies are made of, and this is
Oh,
that
there's a
one.
spectra
they
We're
took
seeing it
spectra.
that look
Okay.
We got some spectra, it looks
13.1
like.
billion years in the past.
That's new.
Less than a billion years after the Big Bang.
Oh, they got a spectrum to say
Elements of oxygen,
13.1 billion years.
hydrogen, as well as neon. This is how the oxygen in our bodies was made in stars.
There's
in
another
galaxies, and we're
naturalistic
seeing
assumption
that
there.
process get started.
Well, it's interesting. They're seeing,
This is now
they
the
pointed out
farthest away
in
galaxy
passing
we've
there
got
that
this sort of
we're
detailed
less than a
information
billion
about
years
what
from the
it's
Big
made of, what
Bang.
it's made of.
And you're
This
seeing
was
neon,
long exposed to the
oxygen,
web.
and other elements. And according to Big Bang cosmogony, you only had hydrogen, helium, and a trifling amount of lithium. All those other elements, oxygen, hydrogen, neon, those things had to be synthesized in stars. That takes time.
Right.
And what's amazed me when they take spectra at very great distances, they keep seeing all these elements as if there's been a lot of nucleosynthesis. And I think that's going to be one of the big surprises, how much product of nucleosynthesis there is all the way back, which I think is a bit of a problem.
Yeah, right.
It's so wonderful to see it pay off.
So thank you, and I'll see you later on today, I hope. So
Yes.
enjoy the day. Right. So from distant galaxies, we now turn our eye to something a bit closer. It's a planet, but not one in our solar system.
Okay, here we go.
Remember that Earth and its sibling planets aren't the only show in the universe. When scientists and engineers started developing JWST, the search for exoplanets wasn't even part of the plan. That's changed. Exploring exoplanets is now a major component of the mission and the subject of our second big reveal of the day. I'm going to send it now to our friends Natalie Willette and Sarah Gallagher at the Canadian Space Agency in Montreal. So again, bonjour. I guess we're having a
little difficulty there. Yeah. Right on, Carrie. Every time you hear a naturalist assumption, just ding that bell there, because there's going to be a lot of them.
Or I could take a drink of cheer wine.
You got plenty back there. You got 2 packs of it back there.
Okay. Yep.
Yeah.
We're all ready. Yeah. Okay, I apologize. We're having some trouble with the signal from Canada, but luckily for us, we have an exoplanet expert right here, just in case that happened. So this is Nicole Colon, and she's an exoplanet scientist at NASA, and we're going to talk about this amazing new result from a very hot planet, I understand about 1,000 light years away.
That's right. The exoplanet is named WASP 96b, and it is this hot, gaseous, giant, puffy planet that it is about 1,000 light years away. So that's why today's release is so exciting, because it teases at what Webb is able to do for such a distant.
Absolutely. So talk us through what this discovery is and why this is so significant.
Well,
So the Patty, a
reveal
naturalist,
that you're
someone
going
that
to see is
buys
going
into
to
the
show
naturalistic
the first
worldview is
spectrum
basically what we mean.
an
So
exoplanet as
in
taken
terms of
from
the
the Webb
naturalistic
telescope.
worldview, we're talking
And
about
this is
someone
exciting
who
because
believes
it
that
covers
nature is all that
infrared
there is.
wavelengths of
Everything
light
is
that
governed
we
by
have not
natural
had
law.
access
There's
to
no supernatural. There's
before.
nothing
So
outside
we've
of
been able to
nature.
use other
Basically,
telescopes
is
to
kind of
explore exoplanet atmospheres in
the
the infrared,
viewpoint that they
not
take,
to
a
this
lot of the
level of
assumptions that they
detail.
take. So that's the
And this
worldview
is
that they
just
bring
one
when they're
sliver
actually looking
of
at the
data
evidence,
that
when they're
Webb is
looking at
providing
everything
us
out in the
using the
universe, all of the
NEAR
stars and
instrument
galaxies.
And there's
They're
something about
assuming with
infrared
their
that's actually
naturalistic
particularly
lens, you
good when
picture like a
interpreting
lens putting
spectrum.
on
So
some
in this
glasses
case,
here. So
what
they're
we're
basically
doing is we're
looking
actually going to
through
take the
it
light,
rather
break it up
than
into
what
a
we would do. We
rainbow,
would put on
and
our
look
biblical
very,
lens,
very
biblical
carefully at
worldview,
how much
and we
color
would
is
interpret
coming
our
in
evidence that
in
way.
each part of the spectrum.
So
So I believe we have that image, if we can put that up.
Okay, they're getting the opposite
We're
atmospheric
revealing the
composition
spectrum
of
right here.
WASP
So we now
96b.
have our
This is
Okay.
spectrum.
not an
So
Earth-like
this is
planet.
exactly what
you're seeing
It's more
as
like
this is
a
described
Jovian
is
planet, a
spectroscopy.
gas
What we
giant.
did was
You're
we
seeing
observed
water
thousands
and a
of
couple other
different
things. I didn't quite
exoplanets.
catch all of
We
those.
observed
Yeah,
the
yeah.
planet
Now, this is only
directly over the
1,000
star.
light years
Now,
or
mind
so
you, this
away,
is not a
80,
direct image. This is
a little over
infrared.
1,000 light years. So
So we've seen the
That's what they
effects
said.
of what
Yeah.
happens when the planet and its atmosphere passes in front of the star. The starlight filters through the atmosphere.
that's a good
And
graphic of what's going
then
on.
you can break
Yeah,
that
they're
down
talking
into
about the
wavelengths of
corona
light,
graph. They're basically
and you get
blocking
a
the
bunch of what
lights
looks
and
like bumps and
being able
wiggles
to
to
see
some
that.
people, but it's actually
And
full
you'll
of
Seeing
see this,
information
see
and
the
different.
spectrum of the atmosphere of
So
the
you're
planet when it
actually
transits
seeing
in front
bumps
of
and
the star,
wiggles
but
that
you don't see it any
indicate the
other time.
presence
Pretty
of water
clear
vapor
indication
in the
that we're not
atmosphere of
just
this
seeing
exoplanet.
weird
So
things.
we
We're
have the
actually
spectrum
seeing
up here.
something
Is there anything
associated
you'd
with
like
the
to
planet. So you
highlight
can
for
see
this
there's
slide?
water vapor.
Yeah, absolutely. So
It's all
we
water, it
have
looks like.
several
Yeah.
features marked here. So I call them features. They're these, what I just referred to as bumps and wiggles. But what
Yeah.
you're seeing here is a telltale signature, the chemical fingerprint of water vapor in these atmospheres, in the atmosphere of this specific exoplanet. And the other
And,
thing we
and
can tell actually is that there's evidence
molecules
of
tend to
clouds and
be in the
haze
infrareds. That's why this is so
because
good
the
for this
water
telescope to do
features are
this.
not quite as
Right.
large as we
And they're
would
talking about
typically.
not only
So
doing it
we
for
can
these
heat gas
exoplanets,
and
but they're
see
also
the thermal
talking about
presence
doing
of
it for the
atmosphere.
Jovian planets in
Right?
our own solar
Now, one
system
thing
as
that we
well,
really
and some
want
of
to
the
make sure you
moons and some of the
understand is that
satellites
this
around, like
particular planet, this is a hot
Saturn and
world. It's
Jupiter
actually
and
closer
all the
to the
rest, trying to
star
look at
than
their
Mercury is to
atmospheric
our
composition
sun.
as well.
And so
So I
we're not
think that
looking
would
at
be
liquid water
really
vapor.
good
We're
observational
looking
science
at
right
sort
there
of
that
steam,
they'll be able
water
to do.
vapor.
Yep.
This is
Seeing lots of
an
water
exoplanet.
vapor.
It's about the size of Jupiter, about half the mass of Jupiter. It orbits around a sun-like star, but it does it every about 3.5 days. So it's extremely hot, extremely close in, nothing like our solar system planets. But that's okay,
Good,
because what we're
good
seeing
point.
is, again, the first exoplanet data from Webb, and this is just the beginning. We're going to start pushing down to further smaller planets and being able to take measurements just like this with the NIRS instrument that was built by the Canadian Space Agency, but also there's three other science instruments that will add to our knowledge in the infrared, as well as direct imaging modes along with the transit method. So there's a lot more to come.
There's a real problem with trying to explain how such a large planet forms so close to a star. It's too hot, and it would have driven off all the volatiles that give you the light gases in the thing. And so they suggest planetary migration. They form very far out, and they migrated in through some very complex interactions, making our solar system unique in that respect.
Right.
So we have
Yeah.
three more big
They were
topics,
expecting
and
to
with that
see a
new
lot of the
rocket
solar
science.
systems, right, similar
But
to
first,
our
let's
own.
talk about
They were
the
expecting to see a lot of Earth-like type of planets, but
Celebrations
it's
like this one are
not
only
that. They're
possible
seeing
with
all
years of
sorts of
hard
different
work and the
flavors
cost of
of
thousands.
different ones, just
When a new
throwing
mission
all
is
of
being
their
built, even the
models.
Yep.
most enthusiastic space fans only get to see dramatic moments in its life cycle, the news and images that come out in updates and press releases. But that doesn't really give you the sense of the huge effort that goes on behind the scenes every day. The plans, schedules, and organization to keep everything moving forward really happens, for the most part, out of people's gaze. Webb started as an idea that took root at NASA Goddard. It grew first into planning teams, research projects, schematics,
So we've
requirements.
seen 2
Then
images
it
so
began
far.
a long journey to become
They're in the
real,
second one
with
here
the
now.
development of new
It's the second one.
technologies, cutting-edge engineering, and finally fabrication.
Should I play that game? Take a sip and cheer one every time they mention something naturalistic.
We all got here today.
Yeah, you might be taking a lot.
You be the judge. You tell me when I have to take a sip. Okay? All right. I only take a sip when you tell me to.
Okay.
You'll be the judge. That Babylon Bee headline's pretty cool.
Yeah, I thought that was a good one, Bart. That was a good comment. I like that one.
Fitting is closed out. There's no more touching of the vehicle. We're ready for launch.
Ariane 5 rocket there. Pretty reliable, pretty powerful rocket there that they used.
The James Webb Space Telescope. Born from the desires of astronomers.
So it sounds like they're going to go,
achieved with
I think, some of
newly
the description of
invented
the telescope
technology.
itself. And
Yep.
yeah, and
Is
just
the culmination
speaking of the mirrors, I thought that was
20
probably
years
one of my
work.
favorite parts of the mission is how they were able to align all of these mirrors. Because you think about it, you have all these
Humanity
different
has
mirrors, 18 different
unlimited
ones,
questions
essentially
about
acting
our
like
universe.
18 different
Engineering
telescopes,
a
if you want to
way
think
to
about it that way,
investigate
that they had
them
to align now to
requires
become one
enormous
cohesive
creativity.
telescope. So in order to make
Webb
that
has been a
happen,
trade-off
um,
between engineering performance, the
they
way
had to
astronomers
align
want
them
it,
within
risk.
fractions
In
of a
fact, when we started
wavelength
20
of a
years
light. They
ago,
said
we
within
were actually
50
looking at an 8-meter
nanometers. So
telescope.
you think about how tiny
Developing
that
the
is in
most
small steps of
sensitive
1/10,000th of diameter of a human
and
hair. So you think
testing
about the electromechanical precision
and
that's,
testing.
that they're talking about there. So Yeah, and so I think they actually gave an analogy on the NASA website to talk about what that mirror alignment actually looks like. So if you imagine each primary mirror segment being the size of Texas, and the primary mirror itself being the size of the United States, you have to be able to align each one of these Texas-sized mirrors to within 1.5 inches. So you think about the precision that they had to
We all got
use
together
in order
in
to
that
get that
conference room and
precisely
played real
aligned.
time as the images
Just
came down
blows my mind.
from the
And
spacecraft.
of course, they're
The very
using their reliable
first
senses. They're
diffractional image
using
of
their
images
their
ever
scientific
obtained
observations
Webb.
to be able to make
And
this
what we
happen. So of
collectively
course, you're
saw
seeing
as a
that
group
borrowing from the
was
biblical
the
worldview in
highest
order to make that happen.
resolution infrared image taken from space ever.
Someone earlier had asked about my latest
You're just
book
joining us.
release
I'm
that I
Michelle
mentioned.
Thaller at NASA's Goddard
So they're
Space
reading the
Flight
Created
Center, and
Cosmos.
you
So
are
the
watching
other you
live
intend to
coverage of the
release.
release of the first science
Well,
images
the
of
most
the James
recent
Webb
book I
Space
have
Telescope.
is
So it's appropriate
Heaven's a
now for us to
Different View.
broadcast to our colleagues and friends
Tom,
at
if
the
you could
Space
bring it in
Telescope
so people
Science
can see
Center
the
in
cover.
Baltimore. That's the scientific nerd center
I'll
of the
hold it up
entire
here
Webb
for you.
mission.
It came out in
So hello,
December.
good morning, Alex.
It's
More
got
than
also
just a coffee table book. It's an amazing
No.
amazing.
It's a coffee table book, but it has some text in there too. It's just beautiful pictures, most of which I did not take. Other people took. I'm not the only one who took photographs. And in fact, the best ones in here are not mine, but I have a few. That Horsehead Nebula here on this side's really cool. So it came out in December. It makes a great gift. But anyway, it's a book with essays in it based in biblical astronomy. So I want to let people know about that. Thanks for asking about that. I wouldn't have thought of actually showing it, but thank you.
And Eric brings up a good question: is the telescope orbiting Earth or stationary at 1 million miles? So essentially, what that 1 million miles means, I think it's technically 940,000 miles to be more precise, but it's at what's called the L2 Lagrange point. So within the Earth-Sun system, there's 5 different Lagrange points. They're basically these very stable kind of orbits, and so L2 is just one of those points, basically, that's past the moon out there, and it's about a million miles away from here. And the cool thing about that is, in order to keep what's called station keeping maneuvers, they're able to keep that to a minimum because the satellite out at that Lagrange point is able to keep in a very stable orientation. So it's able to keep its antenna pointed away from Earth pretty much at all times. It's able to keep its antenna pointed back to Earth, so in order to send all that data back. So just a really cool in terms of how that orbital mechanic works and being able to have that out there so they can basically minimize the fuel because really when it comes down to it's the fuel that's going to dictate how long a lot of these missions last for, right? So you want to make sure you have enough fuel on board to keep those station keeping maneuvers at a minimum. So the L2 Lagrange point really keeps a good kind of orientation that they're able to lock onto there. So and if you go onto NASA's website or any other websites, you can read more about these Lagrange points and kind of how they work. So, but they're pretty cool. And I think they might actually be talking about it here on the screen. If you want to pull that up, Tom, it's basically orbiting kind of around that point. So you can kind of get an idea of where it's at.
Quite a long list. We ended up with about 70 targets, from which we had to select only a handful.
So hopefully that,
that
helps explain a little bit about what
images, what would highlight the instruments, the different 4 science instruments for Webb, and what would highlight the 4 major science themes for Webb. And it's a celebration as well of the beginning of science observations.
And we knew that selecting the images was just the beginning, that we would need a trained eye to take these exquisite data and pull out the beauty and the science potential. So here's Jody Pasquale and Elisa Pagan to tell you about how they processed these beautiful images. And they have it downstairs. I think they missed some of that beginning.
We're basically translating light that we can't see into light that we can see by applying color like red, green, and blue to the different filters that we have from Webb. And the reason we want to color the images is because there's actually more that you can get, more information that you can get from the image if you see it in color.
So it's a matter of picking and choosing filters and colors that enhance the details and the structure in the image itself.
So they're talking about doing the color coding on this.
Infrared light and assign those
as I mentioned before,
and then
we can't see it as wavelength, so we have to color code it so it can make sense out of it.
And then we additively combine those together to get our full color image.
But there is a lot of aesthetics that are involved in this. Painstakingly going through and cleaning these images up with an attention to detail, a level of detail like at the pixel level in every image.
So when I'm working on the astronomical data, it is this sort of marriage between art and science. When you're choosing colors for the filters, you really are trying to show the different details and the processes that are happening in the astronomical images. But at the end of the day, you want it to be very compelling. You want it to be very beautiful because space is beautiful.
And after those images were processed, there was a select few of us, very lucky few of us, who got to see the first images.
Those is downscaled by a factor of 4. Exactly. So it's just to make it a little more handy, so it's actually higher resolution. So we have a team of about 30 people who are producing these images.
You know, Patty Ann was asking about why Mr. Welty didn't talk about this. None of you knew who Mr. Welty was, or is actually still alive. He was a science teacher in high school, science teacher in Fairborn, Ohio, where Patty Ann and I both grew up. Patty, I never had Mr. Welty. One of the few people who never did. I don't know how that happened. But he was quite a character, and still is quite a character, I do believe. But the simple answer would be, well, he was committed probably to naturalism, which is why he never talked about this sort of thing. A few of your science teachers would. They might get in trouble if they did. Hard to say, but yeah, it's a long way from 5 Points Junior High School and Park Hills High School to here, isn't it?
Wow. This near-infrared image is, wow, the detail. Oh.
Okay, this is one of the big ones we want to show us.
Wow, okay, well, here we are. We have a near-infrared image on our left, or on maybe your right. And here on the right, we have a near-infrared image. And so I'm here with Carl, our astronomer specialist. Can you tell us what we're looking at in these images?
So this is a planetary nebula. It's caused by a dying star that has expelled a large fraction of its mass over in successive waves.
Okay, so we actually see those waves in these images.
Yes.
Wow. And so there's a lot of structure. Can you tell us a little more detail about what we're looking? Maybe start with this one on the left.
Yeah. So in the NIRCam image, you see this kind of bubbly, almost foamy appearance throughout the whole nebula with some very structured shells. And this foaminess is showing up in orange mainly, and this is due to the molecular hydrogen that's newly formed in the expansion, just lighting up the gas and dust of this nebula. And then as we move inward, you see this kind of very blue haze in the inner region, and this is actually due to very hot ionized gas that emits well in the blue, that's heated by the core, the leftover very hot core of this star.
And what about these like rays that I'm seeing in this image?
Right, so there's also rays in the outer regions that you can kind of see, and these are holes in the inner nebula that are actually allowing the central star's light to come out and kind of light it up like, patchy clouds with the sun shining through.
Wow, oh yeah, that's what it looks like. That's so cool. So you're actually a mid-infrared astronomer, which is different than near-infrared. And so what can you tell us about the details in this mid-infrared image?
So it looks quite different in color, partly because we're seeing different kinds of physics going on here. So we're actually seeing in the blue, you see a lot of blue. The blue is actually due to hydrocarbon grains that are emitting very strongly in the blue for Miri. And they show the very similar structures to what we see in orange and NIRCam.
And you can see the central star you mentioned earlier. All these views are showing you that star in the middle is a very hot, relatively small star. I think it's the one that's responsible for blowing that gas off in the past.
That's where it emits the strongest for Miri wavelengths.
Okay.
And then as we go into the center, we see kind of
Ian, you asked there about seeing stars dying. This is a relatively nearby object. It's
didn't really see much of
I think it's about 2,000 light years.
But now
it's 8,500 light years. So it's relatively nearby. It's within our own galaxy. It's not looking at the far reaches of the universe.
I can't see it in the first image really, but there's two stars there. So that's a fun surprise. And I think that there's another little Easter egg you want to tell us about?
Yeah, so this was, the Easter egg is this kind of narrow filament up in the top that's radially aligned. You can kind of see it very clearly in the Miri image. It shows up as this blue structure, and it points very much to the central sources. So I thought, oh, this must just be a density enhancement in the outer nebula. I thought that very, very strongly, but other people on the team were like, no, it's a background edge on galaxy. Well,
Yep.
I made a bet that said, no, it's part of the nebula. By the way, I lost the bet because then we looked more carefully at both the NIRCam and Miri images, and it's very clearly an edge on galaxy with a dust lane and a bulge. So I lost the bet.
Well, you lost the bet, but you got these gorgeous images, so I think it's a win for everybody. Anything else you'd like to say today?
I can't wait to see where we go from here.
Neither can I. All right. Thanks so much. Back to you, Michelle.
When they say implied filters, they actually have different wave bands they look at. So they don't look at just one wavelength. They look at, say, 4 or 5 different wavelengths. So those are like light filters. And then they have to balance those and put those together into a single image with color coding. So yeah, it's kind of enhanced in the sense of giving you color coding, but the filters are there because that's the way the system works. I do the same thing in the work I do. We use colored filters. Typically, we do like 4 different colors in the images of stars that I take in my work. It's just a very standard process in astronomy.
Do we have a signal from Perth? I guess nothing from Perth right now.
Yeah, thank you, Carrie, for the double ding there.
Am I supposed to take 2 drinks at this point? Is that what I'm supposed to do?
I think we've been missing quite a few, so you probably just take like 10 or 15.
I'll get started here. We're starting late, but it's chair wine. Relax, folks. It's a cherry soda. It's not alcoholic, okay?
Yeah, that's right.
So
Planetarium, everybody's enjoying the show.
Bottoms up.
Here's to you, Sally Ann.
Hey, Dayton, Ohio.
We're starting now, but when you get a ding, I have to drink. So
Yep, there you go.
Dayton, Ohio. Hello, everybody, Dayton. Nice
So we need Sally and Carrie to keep us on our game here.
Yes.
Hey, Dayton. Hey. They're jumping up and down.
Okay, Donald Smith asked, where does a star get its energy source from that's lasted 13 billion years? Well, we believe stars fuse hydrogen into helium in their cores. There's actually direct evidence from neutrinos coming from the solar core that confirms that. We've learned that in the last couple of decades. The sun could shine by this method 8 or 10 billion years. We can do calculations. It's not very hard. I've done it with students before. More massive stars don't last as long. That doesn't mean the stars are that old, just simply means they could last that long. But you'll notice the sun, its maximum time length, lifetime is less than 13 billion years. So the sun and most other stars are not primordial. The astronomers know that. They realize that stars like the sun could not have formed early in the Big Bang universe. In fact, according to standard interpretation, the sun formed about 9 billion years after the Big Bang. So there are plenty of other stars that formed in the intervening 9 billion years, according to the standard understanding of cosmology and stellar astronomy.
So, I mean, at NASA, we are so fortunate to have all of
That's sad to hear, Bill. No true wine in Florida.
Is the European Space Agency.
Okay, as again asked here, is there anything new discovery in the field of cosmology or astronomy relevant that there is a need for a book within the creationist perspective to be revised? Well, I wrote a book on cosmology 20 years ago called Universe by Design, and I've changed my mind about a couple of things, and I need to address that. It's not so much the cosmology change. I changed my understanding of cosmology, so I do need to revise that book. I don't know if I'll be able to do that. And then there have been a few other changes that have taken place. More stuff dealing with parallel universes, or I should say, other universes out there. Refinements in the Big Bang model. So yeah, 20 years is a long time. That book could stand some revising. Well, Bill, it depends where you are in Florida. They do have it in northern Florida, Cheerwine. In fact, if you're in Jacksonville, there's a barbecue place. I think it's called Five Rivers. I think I've been there several times, and they have it on tap. I love barbecue and I love Cheerwine. It doesn't get any better than that.
Wow, that's amazing. All right, so I think we're going to start to wrap up here. Do you have any other final thoughts you want to end on here, Danny, before we
Well, let's see. They've gotten to 3 of the photographs. There are 2 more. They're expecting one from the Eta Carina Nebula and one from Stephan's quintet. I don't know if we're going to continue broadcasting, waiting for those. This could go on for another hour or 2.
Yeah, it's going to keep going on. For a while. Yeah. Yeah, overall, yeah, the awesome, amazing images just continue to show the amazing works of our awesome God, of our awesome Creator, of course, and that's why we want to study the universe. That's why we want to study the heavens, so we can observe the awesome glory of our God, and that really should continue as Christians. We need to remember that. We need to continue striving for that, making sure we're always looking at the evidence with the biblical worldview, starting with the solid rock, which is God's word. That never changes, of course, that's always consistent because our God never changes, rather than putting our beliefs and our systems onto the shifting sands of man's opinion. So make sure we're always continuing to remember, yeah, it's the very beginning, like Sheila was saying, in the beginning, God created the heavens and the earth. Let's remember to base all of our thinking from the very beginning, Genesis 1:1, without compromise, of course, and let's continue to stand on that biblical authority and to continue to preach the gospel as well, of course, because like we say all the time, we're a biblical authority ministry. We love to give you guys answers to a lot of these situations about, in terms of astronomy, cosmology, a lot of the stuff that we see out into the night sky. We love giving you answers to defend your faith, but really we are all about the gospel. We're all about proclaiming the good news of Jesus Christ and what he did for us guilty sinners. And Jesus Christ not only being the Redeemer, but he's the creator of everything. All of the stars you see out there, he created all of it, like it says in John 1 and Colossians as well. And he is the sustainer as well, like it says in Hebrews, that he sustains everything by the word of his power. And let's continue to remember Psalm 147:4, which says he determines the number of the stars. He gives to all of them their names. You think about the number of stars out there, right? I don't know what the latest estimate, Danny, is in terms of how many galaxies we've actually observed, or how many we think, and how many stars are within those galaxies. But it's a number that none of us can even count. And God has named every single one of them, and it just shows the awesome power of our amazing God. So we want to just thank you to everyone for tuning in. Thank you for all the comments as well, and appreciate you guys hanging out with us as we were watching, and continuing to be patient with the NASA live feed. And hopefully everyone learned a few things here, of course. And if you guys want to learn more about what the Bible actually says in terms of astronomy, we have a whole section on our website, answersingenesis.org. You just click on astronomy. You'll be able to spend millions and billions of years on our website, of course. And Danny Faulkner has a lot of good resources as well. You can go onto the online bookstore. You can look for the In the Heavens book, along with his other resources as well. And we would love to have you guys come as well. We have an awesome planetarium. I don't know if you want to spend maybe just a quick minute talking about that, Danny, in terms of the awesome things that we have happening every single day. We have shows every single day at our planetarium. Really, really cool resource that we have here.
We have 2 regular pre-recorded shows that go on all the time here, just one after another. During the summer, we do have some live shows that we do. I get to those a little longer. We do live shows. I got one tomorrow. That's Wednesday. Usually in the summer on Wednesdays, we try to do one midday. And I always enjoy those because you get to interact with the audience as it used to be. 3 years ago, is just about the time of COVID came. 2.5 years ago, we totally revamped our system there. Everything's new. And we keep adding things to the museum. We're still awaiting the future. We've had a temporary housing of a future Fearfully and Wonderfully Made exhibit that's going to get a permanent location here by the end of summer, I believe. We also got the Borderlands exhibit that opened last year. We keep adding things. We keep adding things to the Ark encounter as well. So if you've been here and you think you've been here, well, you haven't, because we keep changing it. You need to come back in a couple of years just to see how much we've changed, and then catch up on some more of the live presentations we have. During the summer in particular, it's a very full schedule here.
Yeah, I think the Fearfully and Wonderfully Made is coming around sometime this fall. And here's a cool picture here of the planetarium. And one of my kids' favorite ones is there's an aliens one as well. It talks about aliens, facts or fiction. Of course, it's really fun, you know, with the little cartoons and everything like that, and talking about, you know, do aliens exist? What do aliens look like? You know, in terms of the biblical worldview, is there intelligent life out there and all that? It's a really good
Well,
program.
I'm still wondering if there's intelligent life on the Earth.
Yeah, me too. Sometimes I wonder that as well.
I see MC Tune has joined us. Thank you. I appreciate that, MC.
Yeah, cool. All righty. Well, just want to thank everyone again for tuning in. Yeah, and thanks for hanging out with us, and make sure you guys continue standing on God's word and preaching the good news of the gospel. All right.